All right, we're going to be looking at problem number 3 from the harmonic motion problem set. And it's one of my favorites, the extraterrestrial problem. It's a bit of a strange one, but it is fun. All right, so let's go ahead and read it, see what we can kind of figure out from the reading. Researchers find a creature from an alien planet. Its body temperature is varying sinusoidally with time. So what we mean by that, right, is its body temperature is going up and down, right? Sinusoidally, it's creating that sinusoid curve with time. Um, 35 minutes after they start timing, it reaches a high of 120. So that is a data point that we can use. 35 minutes, 120 degrees, and that was a high, so we'll call that a maximum. 20 minutes after that, it reaches its next low. So add 20 minutes onto that, you get 55 minutes. We reach a low of 104 degrees, so that is a minimum. So we have a maximum and a minimum that are right next to each other. It was at its next minimum. So, so what we need to do here is kind of sketch out a graph, kind of see if we can use this information to figure out some particular, like the period, the phase shift, all that sort of thing. First thing is our y-axis. So because these numbers are so large and so far away from 0, I'm going to use a broken scale on my x-axis. I'm going to go ahead and start at, why not? Start at 104. Let's see, 106, 8, 10, 12, 14, 16, 18, 20. I can count by twos here, so I'll do that. It's not exactly incredibly important that we make these graphs super accurate. If we're looking for accuracy from our graphs, it's probably better off to just use Desmos or something like that. So anyway, we have a minimum at 104 and a maximum at 120. So I'll put some guiding lines on here for myself. Okay, and in the middle, our midline there would be the average of those. So that'd be 112. So we have a midline value of 112. Again, if you're not sure, I just averaged those numbers together. So I did 120 plus 104 over 2. We got 112. So that's where we get our midline. But again, don't really need to do that. You could just sort of count it off to however you find that midline. Okay. Now we need to think about these data points we have and kind of think about the x-axis. So we have at 35 minutes, there is a maximum, and at 55 minutes, there's a minimum. When we look at both of our graphs here, let's just look at sine and cosine. So here's a sine curve. Here is a cosine curve. When I'm dealing with a maximum and a minimum and the next minimum, so these are sort of like sequential for each other, I'm either going to be looking at this maximum and this minimum. So I could do that. I could use a sine curve to sort of model it. So this could be 35 minutes and this could be 55 minutes, and I could kind of build the rest of my function from there. I could also do it here where I start at the maximum at 35, and then this is my minimum down here at 55. Doesn't really matter. I don't generally like starting kind of in the middle of it, so I'm not going to use a sine function, even though I certainly could do it, because I'm not really starting my cycle at 35. I'd have to kind of go backwards and figure out what this point was, and that's just kind of creating a little extra work for myself. Whereas here, I know the start, and now I know the middle, and then I can just find the end there and kind of just finish it out. It's a little bit easier to do this as a cosine curve. Another thing that I'm noticing is the scaling here is just quite a bit, if I count by fives, I don't think I'm going to count high enough. I guess I could count by 5. So that's 5, 10, 15, 20, 25, 30. 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. That seems like that'll be enough. Okay, so we have 35, maximum of 120. Okay, that's our, so again, we're using a cosine graph, so we're plotting that one right there. Now we'll plot that minimum. So at 55 minutes, we were at a minimum of 104. This is half my cycle, right? Because that's where the cosine curve is cut in half. So that is 20 minutes. So 20 minutes after that, I'm going to be back up at my maximum, right? The difference between this maximum and this minimum here is half my cycle. So the other half is just going to be another 20 minutes. So it'll be at 75. And I'll be back up at 120, which is our max again. All right. And then in between these, we have our equilibriums. So these are 20 minutes, so it'd be 10 minutes in between them. And there's our quarter points. So now we have a nice single cycle that we could sort of sketch this, see what it looks like. All right. There we go. So now we just need to kind of figure out our different things going on. Right here is our amplitude. So our amplitude is the difference between 120 and 112. So that's going to be 8. Our period is here, the distance from here to here. So this is actually 40 minutes in this case. Right? It's 20 minutes and 20 minutes, so 40 minutes total for our period. Phase shift, we went to the right and we started 35 minutes. So C is 35. D, right here, our midline, D is 112. The only thing we're missing is we need to actually figure out the B value that goes with this period. So B equals 2 pi over 40, which is actually pi over 20. So that's our B value. Okay, I have everything we need to write the equations. Let's just go ahead and do that. Equation. I guess I'll just write here. Y equals 8 cosine pi over 20, x minus 35 plus 112. So there we go. That's our equation. And we should be able to kind of answer any of our questions based on this equation or kind of graphing it on Desmos as well. So let's go ahead and take a look at the next page. All right. So it says, write an equation. Well, we just did that. So let me write it again, just so that I know what it is. Y equals 8 cosine pi over 20, x minus 35 plus 112. All right. So there we go. That's our equation. What is the temperature when they first started timing? So that's going to be T equals 0, time equals 0, or for our problem, X equals 0. So pretty easy for us to calculate that. We could also graphically find this, but right now we're just gonna calculate it this way. So we get Y equals 8 cosine pi over 20, 0 minus 35 plus 112. And I'm going to calculate this. Again, make sure your calculator is in radians. If it's not, you're not going to get the right answer here. Pi over 20, 0 minus 35 plus 112. Okay. So here's my calculation. Hopefully you can see that. Okay, I got 117.65. So I'll round this to 117.7 degrees. Okay. Find the first 3 times after they started timing, which the temperature was 114 degrees. The first 3 times. So we're looking for 3 different times. Again, we could write an equation and solve it. And we will in the future, in a couple problems here, we will look at that. We could replace this with 114 degrees and then solve this for x. Totally valid method, but that's only going to give us 1. And we don't know if it's the first time, the second time, the third time, the 8th time. We don't know which time this is going to be. So what we really need to do is we need to graph this. So we got y equals 8 cosine pi over 20 x minus 35, okay, plus 112. All right, so we know the scaling needs to be adjusted quite a bit. We're just going to scale from 100 on the x-axis to 130. Okay, and the y-axis does need to, or sorry, the x-axis does need to scale a bit. Let's go from -5 to 80. Step by fives. Okay. I don't know if this is the best. I'm just knowing kind of what we scaled by. You can kind of see down here the different numbers. So looking for the first 3 times the temperature is 140. So I'm going to draw in a horizontal line, 114, of y equals 114. And here I can actually see all of the places where my 2 graphs cross. And so these 3 points are our solution. These are the 3 places where we get a temperature of 114, the first 3 places. So our answers here are going to be T equals 3.391, T equals 26.609, and the last one, 43.391. You should notice a connection here between these ones because they are exactly 1 period apart. They're 40 minutes apart. So this is the place where our graph starts repeating, right? We are on that way down and hit 114. And then when we're back on our way down hitting 114, those are exactly a period apart from each other. The next one here will be a period apart from this as well. This one should be 40 minutes away from there. So this one will be 66.609 if we actually found that one as well. But those are the ones that we're looking for that. Again, we could have solved that equation, but the graph is way easier. We can definitely confirm that. We have really good accuracy on this. Just make sure you scale it so you can see these values well. All right, I'm going to go ahead and stop this, and yeah, we'll pick up the next one in the next video.